Hey guys, in this video we are going to take the second question of Newton-Raphson method. Very simple question. F of x we are considering it as e power x minus 3x. Okay, very simple question. Now, what is the first step? We have already discussed this method. What you have to do? First to find out and keep f dash of x. What is f dash of x? E power x differentiation, e power x. F dash of x means differentiation with respect to x. Okay, minus 3x, it will be minus 3. That's it. Okay. Now, we have to find out where the root lies because we have to assume some x0 value initial approximation, right? So, for that we have to find where the root lies. It basically lies between negative and positive values. So, we have to find where the function is negative and positive. So, try out different values. We will start with f of 0. So, f of 0 if you substitute in place of x0, so what will happen? E power 0 minus 3, right? So, e power 0 minus 0, 3 into 0 is 0. So, you will be getting e power 0, 1. Okay, this is a positive value. If I take f of 1, what will happen? E power 1 minus 3. So it will be minus 0.281. So that means here we have got positive value, here we have got negative value. You can try out many values, minus 1, 0, 1, 2, 3. So wherever you are getting positive and negative, there you have to stop and take that interval. That means the root lies for the function, root lies between 0 and 1. So you have to write that for the given equation, a root lies between 0 and 1. Okay, because it is positive and negative. Now, initial approximation you have to assume. So let x naught is equal to initial approximation, because if you don't have initial approximation, we cannot proceed with the formula. Okay, so x naught how to take, that is important thing. So I have discussed in the previous also that you can take in three different ways. First way is that you can consider whatever the value, function value nearer to 0, nearer to 0. Function value, that means f of x value, whatever you have got, here what you have got, 1 and minus 0.281. So which is nearer to 0? This particular value is nearer to 0. So at what value it is nearer to 0? X equal to 1 it is nearer. So I can consider x naught value as 1. That is also there. Correct. Next, second case, that you can take the midpoint of this interval. That means x value is 0 and 1. You can take in a midpoint. Midpoint in the sense here it will be 0 and 1, that means 0.5. Okay, don't think about this value, don't get confused. I am not talking about this value, x value. You have to, x naught will be always this value, between these two value only. Okay, so midpoint of 0 and 1 is 0.5. Third thing is that you can consider, see, x naught you have consider 1, x naught you can consider 0 also. X naught you can consider 0 also. Okay, now you'll be asking three different ways, means three different answers you'll be getting. No, you'll be getting same answer, but iteration, the slight difference will be there. Maybe iteration, one more iteration will be increase or decrease, whatever steps may increase or decrease, it depends on that. Okay, okay, at last you'll be getting the same value, that's it. So x naught in this question I am going to consider what? 0. You can try it with 1, 0.5 and get the answer. You'll be getting the same answer. Okay, anyways, I am starting with what? 0. So here let us proceed with the formula. Xn plus 1 is equal to xn minus f of xn divided by f dash of xn. This is the Newton-Raphson method formula, in which for the first iteration I am going to start with n is equal to 0. So when n is equal to 0, substitute n equal to 0, it will become x1 equal to x0 x0 minus f of x0 divided by f dash of x0. So x0 is basically the initial approximation whatever you have considered. Okay, this is the first iteration. So in which you have to substitute the value. So x0 value is what? 0 I am consider minus f of 0 by f dash of 0. Correct. Now what is f of 0? Already calculated. See here, f of 0 is 1. That means in place of f of x you have to substitute. I hope you understood. Okay, this is f of x, this is f dash of x. Remember. So it will be 0 minus 1 by f dash of x, f dash of 0 you substitute here 0, it will be e power 0 minus 3. So 1 minus 3 is minus 2. Okay, so we will be getting minus minus cancel plus 0.5. Okay, next we'll go for the second iteration. N is equal to 1. So it will be x2 is equal to x1 minus f of x1 divided by f dash of x1. Now what is x1 value? The previous value 0.5 minus f of 0.5 divided by f dash of 0.5. Now what is 0.5 as it is? No, f of 0.5 in the function you have to substitute, remember, in the function. So we will be getting 0.1487 divided by minus 1.35. You can just verify the answer. Okay, so x2 value you will be getting it as, after solving, 0.6100. This is what I am getting. Next, n is equal to 2, I'll substitute. So it will become x3 is equal to x2 minus f dash, f of x2 divided by f dash of x2. Now the thing is that here, why we are going for third iteration? Because if you see, the value of first iteration is 0.5, next iteration I got 0.6100. The error is quite large. Either it should be same or error should be less. Okay, so that's why you are going for this third iteration. Now in third iteration, x2 value we have to consider the previous thing, 0.6100 minus f of 0.6100 divided by f dash of 0.6100. After substituting the values, you will be getting it as, okay. Now n is equal to, I have to take 3, so it will be x3 x4, sorry, x4 is equal to, now there is a difference, slight difference is there, but still we'll take the fourth iteration, x3 minus f of x3 divided by f dash of x3. Now again I am not writing everything, so I'll just substitute directly. So minus you'll be getting 0.000184 divided by minus 1.1431. So after substitution you'll be getting x4 value as 0.619. Okay, so it is approximately same, we can say. So the root here also it is approximately same, so you can stop the process. So you can say that the root of the equation is 0.619. Okay, so this will be the answer.